Integration by recognition is one of the harder topics that's in integration and honestly in the whole VCE methods course, because it's something that a lot of people don't fundamentally understand how it works. But if you understand how integration by recognition works, you'll be able to apply it in any sort of situation. So what I'm going to do is talk about the most basic integration by recognition example and then kind of expand on that with more progressively harder examples. So in this case, what we're going to do as an exercise, without thinking about integration by recognition or any of those steps, is we're going to try and find the derivative of x squared, and then from that we're going to try and find the integral of x dx. And I'm going to show you how these things relate. You should already be kind of preempting how they relate, and it's because integration and differentiation are opposites. And a lot of people forget that when doing integration by recognition, but it's a really important concept to get your head around before we actually do integration by recognition, because that's the key step in order to execute things. So what we do here is we find the derivative of x squared. We know we multiply down by the power and then minus 1 from the power. We know this becomes 2x. Now, you might be thinking, how does this integral, the integral of x dx, relate to the result that we got above? And the reason why it relates is because this statement here is exactly the same as this statement here, just a rearranged version of it. Because we know, again, that differentiation is the opposite of integration. So the integral of 2x with respect to x is equal to x squared plus c. Now, if I know this is true, what I can do to find the integral of x is just divide this expression, and hence this expression, by 2. So therefore, the integral of x dx is just going to equal x squared on 2 plus c. Now, we could already calculate this. We already know that this is the case because we have integration rules that tell us that this is true, namely the power rule that we use for integration. Except there's a lot of integral rules that we don't necessarily know from the formula sheet, but with integration by recognition and using an appropriate derivative, we'll be able to find the appropriate integral. And we'll go through an example of that now. Okay, so now that we talked about a really basic example and how integration by recognition actually works, let's go to an example where we can actually find the integral of something that we don't know from the formula sheet. So in this example, we have two different parts. The first part tells us to find the derivative of x multiplied by log e of x, and then based on that answer, that's kind of given away to us through the word hence, it asks us to determine the integral of log e of x. So let's just have faith and do the first part and hope that the second part actually relates to the first part. And obviously, because this question is structured, it obviously is. So if we find the derivative of x log e x, we just use the product rule. So if we wanted to find this very easily, what we do is we say that this is u, this is v, so therefore this is going to be equal to u v dashed plus v u dashed. So the derivative of x is 1. So we get log e of x, and then the derivative of log e of x is 1 on x. So it'd be plus x multiplied by 1 on x. So we end up getting log e of x plus 1 as our derivative. And just keep in mind, this is d dx x of log e of x is equal to log e of x plus 1. I'm actually going to write that statement here because that's going to help us with the next part. X is equal to log e of x plus 1. Sweet. Now, for part B, determine the integral of log e of x. The key step in this case was the same as the key step in the previous case where we had x squared becoming 2x. We just have to write this in its integral format. So the integral of log e of x plus 1 is equal to x multiplied by log e of x plus c. Essentially, I'm just going to get a different color. This, which is what we derived, comes here. And this, what we differentiate in the first place, goes there. And it's pretty obvious. You just integrate the derivative that we got, and we get our original function back. Now, we know the integral of log e of x plus 1 is equal to this, and we're trying to find the integral of log e of x. So it makes sense that we're trying to get rid of this 1 here. So this plus 1 here, it's kind of a nuisance. If we get rid of that, we get the integral of log e of x. Now, how do we get rid of that? A lot of people would see this and just want to minus 1 straight away to the other side. But we actually can't do that in this case, and that's because the plus 1 is underneath the integral, or within the integral. So what we actually do is we split up this integral into two separate ones. So we've got the integral of log e of x dx plus the integral of 1 dx. And when you see that, you can actually see that we have to integrate 1 before we move it to the other side. X plus c. Now if we integrate 1, what do we get? We know that that becomes x. So what I can do is therefore say that the integral of log e of x is equal to x multiplied by log e of x minus x, because that's from there, moving it to the other side, and then plus c. Sweet. One last thing before we forget, this is where a lot of people would stop the question, right? Now this is technically correct. This integral is technically correct. The integral of log e of x is equal to x multiplied by log e of x minus c. Minus x, sorry, plus c. Now, a lot of people would overlook this, but you can see plus c, plus c, plus c on every line. That's perfectly fine, right? But the problem is that the c here is fine, whatever, that's just part of an integral, right? The c here is also fine because nothing changed on the right-hand side from this step to this step. But then from this step to this step, we actually expect the c to change because we moved an integral to the other side. Because this x here, this integral of 1, which became x, that's going to have its own constant of integration, okay? So when it has its own constant of integration and we move it to the other side, we expect the c to change because the constant of integration is going to affect the other one, right? You essentially combine them together. And a way of imagining it is we can imagine the integral of 1, we could write it as x plus, let's say, c2, and then we move that to the other side, the constants combine together and change. So what I do to kind of remedy the situation is I make this step c1, and then, as I said before, the c doesn't change from step 1 to step 2, but then from this step to this step, it's got to change, okay? So that's why I change this to c1, but I leave this as c just to signify that it's changed from the second last step to the last step.